Hi, hello, welcome to Homeschool. This is your Class 7 Mathematics NCERT or CBSE board. We are in our first chapter, integers, and today we are going to learn about the properties of integers. Already you have some idea in your previous classes, but now in this year we are going to learn about the properties of integers with all the four operations, that is addition, subtraction, multiplication and division. See the properties I have written here: closure property, commutative property, associative property, distributive property and the identities. Let us start with the first property, that is closure property under all four operations. That is addition, this property we are doing, so I just put an arrow mark. Closure property under addition, subtraction, next operation is multiplication, and the next one is division. Okay. Closure property under addition. Let me take any two integers. I will take 5 and minus 2. Let us mark this A and this as B. A and B are any two integers. If we add, what is the result we are going to get? Let us check it out. A plus B is equal to, add the two integers A plus B. A value is 5 and B value is minus 2. Put in bracket. Whenever you have a minus, put in bracket. Now, plus into minus, minus 2. 5 minus 2 is 3. 5 minus 2 is 3. Then what you can say? This is also an integer. It is a positive integer. Okay. So what we need to remember here? Closure property under addition. If A and B are any two integers, the sum is also an integer. Closure property under addition means immediately you should remember where A and B are any two integers, sum of these two integers, the result is also an integer. That is A plus B is equal to C. What is the statement you are going to write here? Integers are closed. Integers are closed under addition. Or you may say closure property is true for addition. Closure property is true for addition also you can write. So let's move with the next operation, subtraction. Again we take same, any two integers. Let me take the same integers. Let me take A 5 and B minus 2. A 5. Subtraction of any two integers, A minus B. Do A minus B, substitute. A value is 5 minus B value is minus 2. Okay. 5 minus into minus plus 2. 5 plus 2 is 7. Okay. So what is this 7? 7 is also an integer. So 7 is also an integer. Therefore what you can say? A minus B is equal to C. If we subtract any two integers, the result is also an integer. That is A minus B is equal to C. We write a statement here, that is integers are closed. Closure property, right? I am saying it as integers are closed under subtraction. Or you may write it as closure property is true for subtraction. Let's move to the next operation, multiplication. Same two integers we take 5 and minus 2. A, this is B value. multiplication of any two integers, that is a into b is equal to, multiply these two, 5 into minus 2. 5 into minus 2, what happens? 5 into 2, it will be 10, plus into minus, minus 10. This is the way we multiply integers. Already we have seen in your second part of integers. I have explained deep about these multiplication, addition, division and all. If you have any doubt, you can go through that video and then come back here. Right? Now, what is this minus 10? It is also an integer. It is a negative integer. Therefore, I say that multiplication of two integers is closed under multiplication. Minus 10 is also an integer. If satisfies, what is the statement we need to write? Therefore, integers are closed under multiplication. Closed under multiplication. Let's move to the next operation. Closure property under division. That is, same two numbers we take. A value is 5 and B value is minus 2. A division A by B I write. A value is 5 by B value is minus 2. Can you divide this? We get a decimal value. Decimal, is it an integer? No. And 5 by minus 2 is also a fraction. Is it an integer? No. Therefore, what we can say? This is not an integer. Therefore, what you can say? Integers are not closed under division. Closure is true for only addition, subtraction and multiplication. Okay, is this clear? Now once again you need to remember, what is a closure property under addition if I ask? A plus B is equal to C. Closure under subtraction, A minus B equal to C. Under multiplication, A into B equal to C. And division, it is not possible. Don't worry about that. And you need to remember A, B, C. Addition asked, you put a plus sign. Subtraction asked, put a minus sign. Multiplication asked, put into. That's it. Okay, is this clear? Sum or subtraction or multiplication, if you do any two integers, the result is also an integer. This is your closure property. I have done by taking only one example, right? And in your textbook, you have many sub-questions in that. You can try remaining problems and check whether it is an integer or not an integer. Next property, commutative property. Again, we are going to see this property in all the operations. Commutative property under addition. What is commutative property? Again, here we take any two integers. Let me take 3 and 7. And we are any two positive integers. I have taken any integers. You can take one positive, one negative, or both negative also you can take. First, let me explain with an example of two positive integers. What is commutative property? The sum of the two integers is equal to sum of the same two integers with a different order. That means, suppose if I add A plus B, change the order, B plus A, right? Is A plus B is equal to B plus C? Let us check it out. A value is 3, B value is 7. A plus B is equal to, A value is 3, B value is 7. 3 plus 7, 10. And let us find this. B plus A is equal to, B value is 7, A value is 3. Yes, 7 plus 3 is also 10. Therefore, when we change the order and do addition, we get the same answer. Therefore, A plus B is equal to B plus A. This is commutative property under addition. How do we write the statement if we prove that? Addition is commutative for integers. Addition is commutative for integers. If A and B are any two integers, A plus B is equal to B plus A. This is commutative property under addition. Then let's go to the subtraction. What we are going to say, same manner. I take the same numbers 3 and 7 itself. Subtraction. A, B. Subtraction, in the place of plus, you need to write minus. A minus B, is it equal to B minus A or not? We need to check. A value is how much? A is equal to 3 and B is equal to 7. Substitute the value 3 minus 7. And here 7 minus 3. 3 minus 7 is minus 4 and 7 minus 3 is 4. Are these two equal? No, they are not equal. This is minus 4 and this is 4. So what you can say? A minus B is not equal to B minus A. Therefore, subtraction is not commutative for integers. Subtraction is not commutative for integers. It is true only for addition. It is not true for subtraction. Let us check for multiplication. A into B, B into A. Let us check out whether these two are equal or not. Same, A value, B value we take. A is equal to 3, B is equal to 7. Substitute in the place of A and B. 3 into 7. 7 into 3. 3 sevens are 21. 7 threes are 21. Yes, it satisfies. Therefore, A into B is equal to B into A is commutative under multiplication for integers. Okay, if you get both same answer, then I can say that the two integers are commutative under multiplication. Okay, if you prove any problem, you need to write a statement here. Therefore, multiplication is commutative for integers. Okay, let's see the commutative property for division. What you can say? A, in the place of plus, you put divide symbol. A divided by B, B divided by A. Change of order of numbers. Let me take same A and B value. A is equal to 3, B equal to 7. 3 divided by 7 and 7 divided by 3. 3 by 7, 7 by 3. Are these two equal? No, they are not equal. So I can say that division is not commutative for integers. Okay, so write the statement. Therefore, division is not commutative. Is not commutative for integers. Okay, so in this property, which are the properties it satisfies? Commutative property under addition and multiplication is true and remaining both are not true. Okay, what we need to remember here? A plus B is equal to B plus A. Suppose commutative for multiplication means A into B is equal to B into A. Okay, Let us see the next property, associative property. In associative property, we are going to take three integers. Let us take A, B, C are any three integers, and we remember this A plus of B plus C is equal to A plus B of plus C. Okay, if we are able to satisfy this, then we say that addition is associative for integers. Let us take any three numbers. If you want, you can take mix with positive and negative integers, or you take only negative integers, or you take only positive integers. Your wish. But let me take mix of positive and negative integers. Let me take A is equal to 3, B is equal to -7, C is equal to 5. Let A, B, C are any integers. I have considered A is equal to 3, B equal to -7, C is equal to 5. And now we are going to substitute in this. A place 3 plus bracket, B value is -7 plus C value is 5. And this side, substitute A value is 3 plus of B value is -7, use with brackets, plus C value is 5. Okay, now first we are going to simplify this one in brackets, then we add with this number. 3 plus of -7 plus 5 will be -2. Okay, and plus into minus 3 minus 2, that is 1 you got. Now this is left hand side and that will be right hand side. Okay, let us simplify this one. Brackets first. Now this one 3 plus into minus 7 plus 5. 3 minus 7 is how much? -4 plus 5. 5 minus 4 will be 1. Yes, it is satisfying. So I put there equal to. What is associative property under addition? A plus of B plus C is equal to A plus B of plus C. If you are able to prove this, what is the statement you are going to say? Therefore, addition is associative for integers. Addition is associative for integers. Okay, let us check for subtraction. Same, wherever you have plus sign, you take minus. That is A minus of B minus C. Equal to or not, we don't know. After proving, we say it is equal or not equal. A minus B of minus C. Okay. Now substitute A, same values I take. A3, B minus 7, C 5. Substitute 3 minus, B value is -7 minus 5. And here A value is 3 minus of -7 minus 5. 3 minus, both are negative. We need to add the numbers and take negative sign. -7 minus 5 will be -12. And here 3 minus into minus plus 7 minus 5. Okay. Minus into, remove this from bracket. Minus into minus plus 3 plus 12. And here 3 plus 7 is 10. Remove from bracket 10 minus 5. 3 plus 12 is 15. 10 minus 5 is 5. So what you can say? Both are not equal. Therefore, subtraction is not associative for integers. Okay, let's move to the multiplication. Same manner, wherever you have plus sign, use into. A into B into C bracket A into B brackets into C. Okay, you need to remember 1 and wherever you have sign, you need to change the sign for the operation. Again, same A, B, C value. A 3, B minus 7, C 5. Substitute 3 into minus 7 into 5. And here 3 into minus 7 into 5. Do inside the brackets first. Minus into plus, it will be minus. 7 5s are 35. Here, do this one. 3 into 7, 21 plus into minus, minus into 5. Into there, right? Here you have plus symbol. Plus into minus, minus. 35 3s are, it will be 105. 3 5s are 15, 3 3s are 9, 10. It is minus 105. Let us see RHS sign. 5 1s are 5, 5 2s are 10. Minus into plus, minus. Then what you can say? Both are equal. Therefore, this is your associative property under multiplication. Therefore, multiplication is associative for integers. Is associative for integers. Okay. Now let's see division. Same manner. A divided by B divided by C and A divided by B divided by C. Now, substitute A, B, C values as A is equal to 3, B equal to minus 7, C is equal to 5. Substitute A, B, C value. 3 divided by minus 7 divided by 5. 3 divided by minus 7 divided by 5. Now, 3 divided by minus 7 by 5 you can say. And here 3 divided by minus 7 divided by 5. Now this one how you are going to simplify? When you are dividing, you just 3 by minus 7 by 5 there. Okay? How do you write this one? As 3 into minus 5 by 7. Then this will be minus 15 by 7 you can say. Same manner, 3 by minus 7, if you divide by 5, what happens? This 5, when it comes to numerator, do the reciprocal and then multiply. That means into 1 by 5. That will be 3 into 1 will be 3, minus 7 into 5 will be minus 35. So, 3 by minus 35, is it equal to minus 15 by 7? No. It is not equal. Therefore, what you can say? Division is not associative for integers. No, it is not associative for integers. So, associative property holds good or it is true for only addition and multiplication. What is the property you need to remember? For addition, A plus of B plus C is equal to A plus B of plus C, and for multiplication A into B into C is equal to A into B into C. Okay, is this clear? Now let's see the next property, distributive property. Distributivity of multiplication over addition. Okay, distributivity of multiplication over addition. What is this? How it will be? Distributivity of multiplication over addition. How to remember this property? Distributivity of multiplication over addition. Here also I take any three integers. Let the three integers be A, B, C. A into B plus C is equal to, how we are going to multiply this? Like that only. You remember, A into B plus A into C. A into B plus A into C. Okay? Distributivity of multiplication over addition. Let us take any three integers and check it out. Let me take A is equal to -1, B is equal to 4, C is equal to 2. Okay? Now, substitute -1 into B value is 4 plus 2. What does it become? -1 into 4 plus 2, 6. Minus into plus. You are multiplying, right? Minus into plus. -1 into 6, 6. That is -6 you got. Let us check the RHS part. A value is -1 into B value is 4 plus A value is -1 into C value is 2. Okay, these first we need to multiply. Minus into plus, minus 4 into 1, 4. Minus into plus, minus 1 into 2, 2. And again this minus, if you multiply plus, minus into plus, it will be minus. When we have both the negative signs, the numbers we need to add and take the negative sign. That is 4 plus 2 is 6, minus 4 minus 2 is minus 6. Yes, it satisfies. Therefore, this is your distributive property of multiplication over addition of integers. So, if it satisfies, what we are going to say? Therefore, distributivity of multiplication over addition is true for integers. What is the statement we need to write? Distributivity of multiplication over addition is true for integers. Okay, I have done with one example. You can go with any 2 or 3 examples. Same manner, we change the statement. What is that statement? Distributivity of multiplication over subtraction. Let us check it out. Okay, let us check this. Distributivity A into multiplication over subtraction B minus C. Whether equal or not, we don't know. A into B minus A into C. You can put brackets here. A into B minus A into C. Same A, B, C values I take. A is equal to -1, B is equal to 4, C is equal to 2. Any 3 integers of your choice you can take. A -1 into B value is 4 minus C value is 2. -1 into 4 minus 2 is 2. Minus into plus, minus 2 ones are 2. Yes? Now, let's move to the RHS side. A value is -1 into B value is 4. Minus -1 into 2. Minus into plus, minus 1 into 4, 4. And here, minus of -2. Okay? Minus into minus, plus 2. Minus 4 plus 2 is -2. Are these two equal? Yes, both are equal. So, what we can say? Distributivity of multiplication over subtraction is true for integers. Okay, is this clear? Distributivity of multiplication over subtraction is true for integers. Next, we are going to see identity. What do you mean by identity? Same. Yes or no? Identity means same. Suppose if I write here additive identity. Additive identity. Okay, suppose if I take any number 2, you add some number to get same value. Identity, same identical number, you should get the result. Take any integer, if you add for that integer, you will get same number. What you add to get same number? Yes, it is 0. So what we say? 0 is called as the additive identity. If you want, you can check with any number. Minus 5 plus 0, minus 5. 100 plus 0, 100. So, if you add a number, you get the same number. If you add anything to the integer, same integer you are going to get as a result. So, therefore, 0 is called as the additive identity. Then, what is subtractive identity? Subtraction. If you subtract any number, you get the same answer. Let me take an integer 3. If you subtract anything, you should get same 3 answer. Again, what you are going to subtract? Same 0 if I subtract, I get the same answer. So, I can say 0 is also a subtractive identity. But we may not use that, no need of writing. Next, coming to multiplicative identity. Suppose if I take any integer, you multiply a number to get same integer. Suppose if you multiply 0, what happens? 0 into anything? 0 it becomes. No, it should not be 0. Same identical number it should be. If I multiply any number to minus 2, I should get the same answer. What is that? Yes, minus 2 once minus 2. Therefore, 1 we call it as a multiplicative identity. Whereas 0 is called as additive identity or subtractive identity and 1 is called as a multiplicative identity. Suppose if I take any number and divide, you should get same number. What you are going to divide? Anything is divided, you should get same answer. What is that? It will be 1. So I can say that 1 is also a divisible identity. Multiplicative identity and divisible identity. But we won't use subtractive identity and divisible identity. We use only additive identity and multiplicative identity. Okay, is this clear? Yes, now we are going to recollect all the formulas what we have learned in this session. First, closure property is true for addition, that is a plus b equal to c. Closure property holds good for addition, subtraction and multiplication. That means a plus b is equal to c, a minus b equal to c and a into b equal to c. Next property, commutative property holds good for only addition and multiplication. That is a plus b is equal to b plus a or a into b is equal to b into a. These are all the formulas you need to remember. Okay. A plus b is equal to b plus a and commutative property under multiplication means a into b equal to b into a. Commutative property does not hold good for subtraction and division. So we need to remember only these two. Then associative property. A plus of b plus c is equal to a plus b of plus c. Associative property holds good for addition and multiplication. A into, I can write like this also. Don't be confused. A into b into c is equal to multiple of any two integers with the third integer, you can say. A into b into c. LHS is equal to RHS or RHS is equal to LHS also, you can say. Next, coming to distributive property. In this, we remember A into B plus C is equal to AB plus AC. A into B plus A into C, or directly you can remember AB plus AC. And one more, A into B minus C is equal to AB minus AC. Okay, coming to identity, 0 is called as the additive identity and 1 is called as the multiplicative identity. Okay, these 4 properties are very important, and identities also you should remember. Application of these you will be having next exercises, right? So I have done with one example. Whereas closure I have taken 2 integers, added, the result is integer or not, we have checked. Same manner for every problem, take 2 more examples and solve. Okay, then you will become perfect about these properties. Okay, with this I am going to end my session today. In our next session we are going to continue with the exercise. Until then, keep watching. Thank you all.